Question number 3. We have the probability of A is 0.37, the probability of B is 0.55, and the probability of A intersect B is 0.13. Find, and then we've got 4 things to find. And it gives us the hint that we should draw a Venn diagram with the given information. So let's start with the Venn diagram. We have some universal set. Inside that, there is a set A, and there is a set B. Now, we know that the probability of A intersect B is 0.13, so 0.13 would actually go in this area, right, Laura? And since the probability of A is 0.37, we need a total inside the circle of A as 0.37. That would mean we'd need 0.24, I believe it is, in this part of circle A, because that would add together to give a total probability of 0.37. Now the probability of B is 0.55. If we take the 0.13 away from 0.55, we get 0.42, and that would be what goes here. Now, we also need to find the region inside the rectangle that's outside both circles. So if we add 0.42 and 0.13, that's 0.55, plus 0.24, that's 0.79, we get 0.21 left, which would go out here. Okay? Now, I think we're ready. What is the probability of A union B? Well, we already added 0.24, 0.13, and 0.42, and we got 0.79. Now, I can't not say this. We also know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And they gave us all 3 of those numbers, so let's go ahead and just figure this out that way also. It would be 0.37 plus 0.55 minus 0.13. 0.37 plus 0.55 is 0.8, 0.92. 0.92 minus 0.13 would be 0.79. So notice that works in that particular way also. The A question could have been done without the Venn diagram. Now, the rest of them maybe not so much. Well, I don't know, as I look at some of these, they're probably not that difficult. What's the probability of the complement of A? That one's really pretty easy because the complement of A, the probability of the complement of A is what you would add to the probability of A to get 1. Or in other words, the probability of the complement of A would simply be 1 minus 0.37, which is, what is that, 0.63? Now the probability of the complement of B, same way. Probability of the complement of B is going to be 1 minus 0.55, which I believe is 0.45. And then finally, what is the probability of A intersect B complement? Now, if you look at the Venn diagram, the Venn diagram is helping us a lot on this one. We want everything that's inside circle A and outside circle B. And it's an intersection, so it has to be both. So if you look at this, the part that is inside circle A and outside circle B is this region right here. So obviously the answer is 0.24. And that takes care of problem number 3.